Exercise 2.1, question 6 to 10. The previous sums of this exercise, question 1 to 5, I have done in the previous video. You can go through that. In this video, we are going to start with question 6. Use Euclid's division algorithm to find the highest common factor, HCF, of 340 and 412. In lower classes, you learnt about HCF. You used to factorize the two numbers and then find the HCF. Now we are going to use the Euclid's division algorithm. Okay, so these are the two numbers. We are going to write these two numbers in the form of A is equal to BQ plus R. Okay, so here the bigger number will be A. 412, write it as A, that is the dividend, and 340 will be B. Okay, that is the divisor. Okay, now if you do the division, you will get the quotient and the remainder. So Q is 1 and remainder is 72. So this is written in the form of A is equal to BQ plus R. That is Euclid's lemma form. Okay, so always be careful. You should take the higher number as A and the lower number as B. Okay. Now here you can see that this remainder 72 is not equal to 0. So again we are going to write the lemma, but this time we are going to take this B value as A and this remainder R as B, the divisor. Okay. Now 340 becomes the dividend. This 72 becomes the divisor B. Okay. And now you divide, you will get the quotient and the remainder. So write it. A is equal to BQ plus R. Here again you can see R is not equal to 0. Again the next step, I will take this B and make it A and this R as B. So 72 is equal to 52 into 1 plus 20. Okay, I get the remainder R as 20. You have to actually do the division to get the value of Q and R in a rough paper. Okay, so here R is equal to 20, not equal to 0. Again take 52 as A, 20 as B. So 52 is equal to 20 into 2 plus 12. Again not equal to 0, R is not equal to 0. Then again 20 is equal to 12 into 1 plus 8. Again R is 8, not equal to 0. Again let's take 12 is equal to 8 into 1 plus 4. Again R is not equal to 0. Then again applying Euclid's division algorithm. Write down again 8 is equal to 4 into 2 plus 0. So here the remainder has become 0 now. So now you should be careful. You should take this divisor B, the value of B. Here it is 4. Okay, that will be the HCF of these two numbers. Okay, so this is the way you should do the sum. Let us go to the next sum. It will be more clear. Okay, let's find use Euclid's division algorithm to find the highest common factor of 867 and 255. So here I told you should look at the bigger number. You will take it as A, smaller number as B. Do the actual division. You will get the quotient 3 and the remainder 102. Write it in this form. A is equal to BQ plus R. R is 102, not equal to 0. Again take 255 as A, 102 as B. Find Q and R and write it. So A is equal to 255 is equal to 102 multiplied by 2 plus 51. R is not equal to 0. Again 102 is equal to 51 into 2 plus 0. So R has become 0. Remainder is 0. That means this divisor is the HCF. The value of B should be the HCF. Okay, so these are the two numbers, 10,224 and 9,648. So write down this is the bigger number. 10,224 is equal to 9648 multiplied by 1 plus 576. R is equal to 576, not equal to 0. Take this as A is equal to 576 into 16 plus 432. Okay, again r is not equal to 0. So take 576 here and divisor, this remainder will become the divisor, 432. Divide, you will get quotient 1, remainder 144. Again, it is not equal to 0. So this 432 is equal to 144 multiplied by 3 plus 0. So now the remainder has become 0. Therefore, 144 is the HCF of these two numbers. Use Euclid's division algorithm to find the highest common factor HCF of. Now they have given us 3 numbers. Very simple. First we should take these 2 numbers, and whatever HCF we will get, we should take that number and 120 and find the HCF. Okay, let's take 84 and 90. So 90 is equal to 84 into 1 plus 6. R is not equal to 0. So 84 is equal to 6 into 14 plus 0. So here 6 is the HCF. You should be always careful. Don't take 14. Okay, the 6, the divisor. See, this remainder becomes the divisor. It is that which will be the HCF. Okay, 6 is the HCF of these 2 numbers. Now we have to find the HCF of 6 and 120. Okay, now let's write down 120 is the bigger number. So 120 is equal to 6 multiplied by 20 plus 0. So here again remainder is 0. Therefore 6 is the HCF. The divisor is the HCF. So 6 is the HCF of all the 3 numbers. Find the largest number which divides 1230 and 1926, leaving a remainder of 12 in each case. Since it leaves a remainder, okay, we should subtract this remainder. So these are the 2 numbers. Now we have to find the HCF of these 2 numbers. Okay, now the bigger number is obviously 1914. So write it. 1914 is equal to 1218 multiplied by 1 plus 696. It's not equal to 0. So again 1218 is equal to 696 into 1 plus 522. Again we have to do 696 is equal to 522 multiplied by 1 plus 174. Again 522 is equal to 174 into 3 plus 0. We got 0. We should stop it here itself. So this 174 is the HCF of these 2 numbers. Okay. If D is the highest common factor of 32 and 60, find X and Y satisfying this equation. So they are given D as the highest common factor of 32 and 60. Let us first find out what is this value of D. So 60 and 32, the bigger number is 60. So is equal to 32 into 1 plus 28. Not equal to 0. So 32 is equal to 28 into 1 plus 4. Again 28 is equal to 4 into 7 plus 0. So 4 is the HCF of 32 and 60. So we found the value of HCF, which is the D value. Here in this formula, D, they are saying no, it's a highest common factor. So D is equal to 4. Okay. Now here we have to find the values of X and Y. Okay. So now what we are going to do is take this equation. 32 is equal to 28 into 1. So what does this mean? 4 is equal to 32 minus, this goes on the other side. That means 4 is equal to 32 minus 28. Okay. So now what we are going to do, this value of 28, we are going to substitute from here. 28 is equal to 60 minus 32. So write down here. Substitute. So you get 4 is equal to 32 minus this 28 is 60 minus 32. Open the bracket, it will be minus 60 plus 32. Okay, now this is what? 2 into 32 minus 60. Write it in this form so that it will be easy to compare. So 4 is equal to 32 into 2 plus minus 1 into 60. Now if you compare with this formula, you can see that X is equal to 2 and Y is equal to minus 1. Okay. A positive integer when divided by 88 gives the remainder 61. What will be the remainder when the same number is divided by 11? Okay, let that positive integer be a. Now let's write down the lemma for it. So it is divided by 88. So the value of b is 88. A is equal to 88q plus r. R they have given, remainder is 61. So 61. So A is equal to 88q plus 61. Okay, this is the lemma. Now they are saying that this positive integer when divided by the same number, when divided by 11, what will be the remainder? Okay, so now we are going to divide this number by 11. Okay, so here if we divide this RHS by 11, this part will be divisible because 88 divided by 11, it can be divided. Let us try to divide 61 by 11. Write down here the lemma. 61 is equal to, divisor is 11. 11 into 5 plus 6. So if we divide this portion by 11, we get the remainder 6. Okay. Question 10. Prove that two consecutive positive integers are always co-prime. Let two consecutive numbers be n and n plus 1. So if the first number is n, obviously the next number will be n plus 1 because they are consecutive. Now, they are always co-prime. Two numbers are co-prime if the HCF of those two numbers is 1. Okay. Now let us see if the HCF of these two numbers is 1 or not. Okay. Let's write down the lemma for this. Obviously this is the bigger number. So n plus 1 is equal to n into 1 plus 1. Okay. Here the remainder is not equal to 0. Again write the lemma. N is equal to n into 1 plus 0. So now the value of r is 0. So here the divisor, see here the remainder becomes the divisor, isn't not? So this is the HCF. HCF of n and n plus 1 is 1. So this shows us that n and n plus 1 are always co-prime. So here we come to the end of the exercise.